In the previous videos, we studied matching problems, focusing on two-sided matching, and each side has a preference over the other side. In this video, I'm going to introduce assignment problems, which is quite similar to the matching problems, but one side consists of objectives. So the people in this side has a preference over the objectives, but the objectives have no preference over the people. So that's the assignment problem. Consider this situation. In the Christmas morning, Alice, Bob, and Chris get 3 gifts P, X, W from Santa. But Santa did not specify who is assigned to what. So their preferences are given this. For instance, Alice prefers W over P and X. Mom randomly assigns Alice PS4, Bob, Xbox, and Chris Wii. Are they happy with this? So we are interested in this assignment has good property, for instance, efficiency. So is this particular assignment efficient? Alice got PS4 and Bob got Xbox and Chris got Wii. This is not efficient because Alice and Chris can be better off by switching their gift. So Alice can be better off by taking W and Chris can be better off by taking P. So they switch their gift. Then they can be better off. So this assignment is not efficient. So how we can find an efficient assignment? Can we use the default acceptance algorithm that we used for matching problem? The answer is no, because the objectives have no preferences. So this is a assignment problem with public endowment. We have a set of individuals I and set of objectives K, and each individual has a preference over the objectives, and the individuals have no objective endowed initially. So that's what we call the public endowment. Those objectives are public before assign the objectives. And importantly, objectives have no preference. So that's what we call assignment problem. So assignment problem is a special class of matching problem where one side has no preference over the other side. So how we can find a efficient assignment? So the answer is quite simple. So we can use this serial dictatorship algorithm. So given any order, individuals sequentially choose their most preferred objective available. Of course, the order can be randomly determined, then the algorithm is going to be a random serial dictatorship. This serial dictatorship algorithm gives us an efficient matching for any order. So we don't need to worry about the order, but any order, this mechanism or this algorithm is an efficient matching. So let me use the serial dictatorship to find an efficient assignment in that example. So we have 6 possible orders: ABC, ACB, BAC, and so on. So each possible order, we can find an efficient assignment. So for instance, in the order of ABC, A comes first and A chooses W. So A chooses W. And then B arrives next and B chooses P because P is most preferred item and it is still available. So B chooses P. And C wanted to choose P, but P is not available. And next preferred one is W, but W is not available. So only available objective is X. So she should take X. This is an efficient assignment. And similarly, for instance, if we consider another order, for instance, CBA, then C comes first, then C takes P, and then B takes, P is now available, so B takes X, and A takes W, because W is still available. So this is another efficient allocation. So in any order, the outcome is efficient because the first dictator cannot be better off because he or she already choose their most favorite objective. And any change that makes the second dictator better off must make the first dictator worse off. To make anyone better off, it must make someone who came earlier worse off. So any order, this serial dictatorship algorithm gives us an efficient assignment.